Hi, this is Steve with iFLOW and welcome to our video series. In this segment we're going to be looking at cycling reduction. So we kind of looked at cycling in the previous segment, and now we want to look at why and how we can reduce that cycling, and really it's because of decreasing heat loads. So some of today's most common HVAC challenges are here on the board. We're going to look at number one is heat loads are decreasing. So we've got improved building technology. We've got better windows, better doors, better insulation, better house wrap. The heat losses are coming way down. The cooling loads are increasing. So even though the window technology is getting better, the amount of square footage of windows that we're putting in is increased, so the window to wall ratio is up, and thus cooling loads are up. Summers are also seeming to be getting hotter, and that trend may continue, so the increase in cooling loads will continue. So the problem for HVAC equipment is that as the heating loads decrease and the cooling loads increase, and then we've got some circulation, more people are using their fans and circulating it regularly, we've got three different CFM rates. We've got a CFM rate for the heating, we've got a CFM rate for the cooling, and we've got a CFM rate for the circulation. All could be different. How are we going to size not only the equipment but the ducting, and then set those CFM rates on the equipment with limited dip switches and options for that. Then ventilation, so the V in HVAC unfortunately is almost always ignored, and how to properly integrate that is almost never discussed, unfortunately. But with that being said, we've got these heating loads that we're looking at, and we'll look at cycling as it relates to the heating loads. So if we look at this furnace, so this is so what I did is I went on to the AHRI or the Energy Star site, and I pulled down the top furnaces on the Energy Star site. This was a Carrier furnace. This is the MN 59MN7. It has an AFUE of 98.5. It is an Energy Star unit. It's got 4 models that are Energy Star rated from 60 to 120. So 60, 80, 100, and 120,000 BTUs. This is a great furnace in that it modulates in 1% increments. So just like the iFLOW modulates in 1% increments, we go from 0 to 100%. They go from 40 to 100%. But they do the burner, the conversion, so we've got to give them some slack there for sure. But again, what this means is they modulate in 1% increments from 40 to 100%. So when we take our maximum input at 60,000 and we multiply it by 40, because that's the minimum rate, 40%, we get 24,000 BTUs. So what it means is, from 24,000 to 60,000 BTUs, this furnace will modulate in 1% increments. So if my heat loss is 35, 40,000 BTUs, awesome furnace. I'm sure it'll do very well. The efficiencies will be decent, and the modulation rate will be very good because it's modulating within the range. If it's below 24,000, how do you think it's going to work? We'll take a look. Turn down ratios, 2.5 to 1 on each one of these models. Like we hope to see that higher in the future, but that's this one furnace. So I think on paper, if the homeowner was to look at this furnace, they would think this is an excellent furnace. Hey, AFUE of 98.5, Energy Star rated, fully modulating in 1% increments. That's great control, great precision. From 40 to 100%, yeah, it sounds good. I can modulate down to 40%. But here's the issue again. If we relate it back to the car and the driving, right? If I'm driving down the highway and I need to go based on that distribution, 12,000 or 12 miles an hour, driving at 24 is still too high, or it's too cold or too fast. So I can't slow this down, and I'm going to have to stop and start to be able to make that happen. So that was the Carrier. Now let's look at Lennox. And again, I was just looking at the very top of the Energy Star performers in terms of efficiency. This has an AFUE of 98.7. It's the Lennox SLP, so Signature Lennox Premium unit. There are 6 Energy Star models starting at 66,000 BTUs. So I looked at the 66,000 BTU model. It can modulate again in 1% increments, so very similar to the Carrier, but between 35 and 100%. So we take the 66,000 BTUs, multiplied by 35% to get the minimum, and we get 23,000 BTUs. So again, between 20, if your home's heat loss is between 23 and 66,000 BTUs, so let's say it's 50,000 BTUs, this would be a great furnace. You're going to get great efficiency, great modulation, should be an excellent choice for your home. If your heat load is below 23,000 BTUs, again, how do you think it's going to operate? Unfortunately, this is the minimum it can modulate down to, so if my heat loss is 18,000 BTUs or 12,000 BTUs, I'm going to be cycling. There is nothing more I can do to it, unfortunately. So here is the crux of the issue, and the reason why we need to look very seriously at the minimum inputs as well as the maximum inputs when we're selecting heating equipment. This is a distribution of homes in the US. So again, we have 5 different locations. The blue line represents Madison, Wisconsin. The orange line represents Albany, New York. The gray line represents Portland, Oregon in the northwest. The yellow line represents Los Angeles in the southwest. And then Birmingham, Alabama is in green, representing the southeast. So you look at all of these distributions, and we have a 60,000 BTU furnace installed in a 1,600 square foot home. This is the distribution that we expect from each of those homes in each of those different areas. What this shows us is the majority of the distribution falls well below 50% capacity of this 60,000 BTU furnace, so well below 30,000 BTUs. In fact, the majority is below even 40,000 BTUs or 24,000, 40% or 24,000 BTUs. So this distribution, this is where most of the heating is, and if you look, the biggest distribution from not only Madison but Albany, Portland, and Birmingham, so this is the one where the demand is highest, is 20% or 12,000 BTUs. So when we look at 12,000 BTUs, that's a very, very low input. If we look at this furnace, right, the minimum input was 23,000 BTUs. This furnace, 24,000 BTUs. But when we actually look at demand, we see the majority of the demand is 12,000 BTUs in this distribution. So this is the US. Let's see about Canada. Let's see if our results are similar. So in Canada, we have 4 locations. We have Toronto, Ottawa, Calgary, and Regina. Regina is the coldest coldest of the 4 cities that we're looking at. That would be north of the Dakotas. We've got 3 different housing types here. So we've got our basic or let's say standard housing design, and then we've got ESNH, which is Energy Star for new homes. So this would be a better standard. This is 20% better than our basic. And then we've got our R2000, which is, let's say, our premium build, our most efficient build. And then we've got net zero even beyond that. But let's look at the heat losses. So from each of these houses, so even the coldest point in Canada not the coldest point in Canada. The coldest point of these 4 homes, or these 4 locations, these 4 cities, is just under 30, so 28,000 BTUs. Now what does that mean? In the worst day of winter, that is my design load. So in the coldest day of January or February, that's where I can expect to see that number. So that may be 1 week a year, 2 weeks a year, 1 month a year. The rest of the time it's going to be below that. So worst case scenario, my heat loss on this 1,400 square foot single detached home is 28,000 BTUs. If I build for Energy Star for new home standard, now I'm 23,000 BTUs. If I build to R2000, now I'm about 16,000 BTUs, and that's a brand new home in the coldest part of Canada, or one of the colder parts of Canada. If I'm looking at Toronto, my total heat loss on the worst design day of winter on basic construction, under 20,000 BTUs. If I go to Energy Star for new home, now I'm 16,000 BTUs. So all to say, the heat loads are very low, so the GTI data is supported by what we're finding in Canada as well. This looks at 4 different housing types in, again, 4 different cities. We're looking at Toronto, Ottawa, Calgary, and this time Saskatoon, not Regina, but Saskatoon is 3 hours north of Regina, so this would be even a little bit colder. We've got a 3-story town, we have 2-story single detached, and then 2 back-to-back stacked towns. So if we look at the coldest area, so let's look at Saskatoon, our heating load, 22,000 BTUs on the town, 23,000 BTUs on the 2-story, 28,000 on the single-story. That's a little bit surprising. And then 9,000 BTUs on the back-to-back town. In Toronto, same house, 15,000 BTUs, 16,000 BTUs, 20,000 BTUs, and 7,000 BTUs. So again, the data that GTI has presented is borne out by the same data that we're seeing in Canada. So whether it's in the US or Canada, heating loads are coming down significantly. So this takes one house, so this 1,400 square foot single detached home in Calgary. This is our heat load, 23,000 BTUs, and again, if we zone it, we have 7,500, 7,600, 8,000 BTUs as the heat load for this home. If we were looking at Energy Star for new homes, that's 20% better, or 20% better, so the standard build would be 20% worse. It's 28,000 BTUs. So again, very, very low. So if we go back to this distribution, let's look at how regular furnaces in the market will react to this, or will operate. So let's look at an 80,000 BTU furnace. Why an 80,000 BTU furnace? Because it's the #1 selling input furnace in North America. So still. And we'll go to a 2-stage unit. So we're not even going to start at a single stage. We're going to go to a 2-stage unit. And we see here that stage 1 is 70% of maximum. So it's going to operate at 56,000 BTUs at its minimum. And then we'll ramp up to 80,000 BTUs when needed. So if we have this furnace, which again is the #1 selling furnace in North America, the #1 sized furnace selling in North America, if we have that installed in this home, how is it going to operate? It's going to be cycling terribly, in that most of the distribution is way less than even half of what the minimum input is. So this 2-stage furnace isn't going to help us at all. It's going to be cycling like a single stage. You might as well buy a single stage, forget the 2-stage. Buy the single stage, it's not going to be any better at all. Now let's look at the second biggest selling SKU in North America, which is a 60,000 BTU furnace. And again, we'll look at a 2-stage unit. So stage 1 will operate at 42,000 BTUs, or 70% of maximum, and then stage 2 will come on at 60. Well, let's look at how often does this 60,000 BTU furnace come on at 60,000? 0. Almost never. Almost never. So how often does it come on at 42,000 BTUs? Well, you can see not very often and only in a couple of locations. So in Madison, Wisconsin, so we said a little bit of blue here, a little bit of blue here. So understood, right? We know Madison is cold in the winter. I'm not surprised to see a little bit of operation here, but that's nowhere near the operation that you're getting at 20% or 12,000 BTUs or 18,000 BTUs. So the majority of the operating time is here. How is this furnace going to react when it needs 18,000 BTUs or 12,000 BTUs in the home and it's able to deliver 42? Again, cycling on, off, on, off. That's like driving your car at 42 miles an hour when you only need 12 miles an hour or 18 miles an hour, right? You're going way too fast, delivering way too much, so you're going to have to slow down, you're going to have to stop, right? Now, when you cycle, right, when you cycle off, the furnace that has, right, the heat is built up in the heat exchanger, then it cycles off, it has to then dump that heat out the exhaust. So every time it cycles, you're going to get a drop in efficiency. And the more it cycles, so the lower the input, the more it's going to cycle, because we can't deliver even 42,000 BTUs. If I only need 6,000 BTUs or 12,000 BTUs, I deliver the 42, which is my stage 1 operation on my 60,000 BTU furnace. I deliver the 42,000 BTUs worth, and then I stop, I pull back, right? Stop, let the temperature drop again, then I come on, blow it hard, blow lots of heat, lots of heat, lots of heat, stop, let the temperature drop, blow lots of heat, lots of heat, lots of heat, and then drop. So you see the temperature's going up and down and up and down. So it's comfortable. It's a comfort issue, right? You're not going to be comfortable with the furnace operating that, and then your efficiency is going to drop to make it even worse. So now you've got two situations. You're not comfortable and you're paying more because your unit's cycling. That's not great. It's not sized properly for the application. So you can see that this red line represents a 95% AFUE two-stage furnace operating under these conditions. And what we see is that even though it's got a stated AFUE of 95%, it doesn't hit 95% until you're about 30%, or sorry, 50%, 30,000 BTUs worth of heat required. Then you start to hit those higher numbers. Anything below that, because you're cycling so quickly, right? You're on for a little bit, then you're off. You're on for a little bit, you're off. The efficiency drops significantly, but unfortunately, that's where a lot of the distribution is. So, for example, if I'm at 6,000 BTUs, I need this amount of heat. What am I operating at? 85. If I'm operating at 5%, I'm well below 80. So, and if I'm at 12%, I'm operating about 90%. So even though the furnace has a steady an AFUE of 95%, it will not be operating at 95% for most of the time you're operating. You know, it'll hit 95 at this range and for here, but all of this operation, which is the majority of your operation, is going to be at below your AFUE number because of the cycling. So, is there a better solution? That's the question. Is there a better solution? And we believe there is. So in this case, GTI has tested the iFLOW, so our unit, with the Navion NPE A series. And they put it in combination. And this orange curve is the performance based on that same distribution when compared with that two-stage 95% AFUE furnace. So I've just overlaid the two lines, and you can see that that is the performance improvement. So this area in green is all performance improvement of the iFLOW over a 95% AFUE two-stage furnace. And that represents dollars. That's savings for you, the homeowner, and that's greener, right? Or less emissions. So it's a greener solution, and it's a more efficient solution, saving you money. And it'll be more comfortable as well because we're not cycling as often. And that is where most of the distribution is. So our performance advantage is where most of the heating is, and that's why we can get a 15% improvement. You would think, well, okay, if it's a 95% furnace and you're 15% better, how do we get the 15% improvement? That would mean you're 110%. Well, no. If your efficiency is only 75% or 80%, and we can bring it up to 90, 95, that's where we're getting the gain. That's where we're getting the improvement. So this is the 15% improvement over the furnace. So now let's go back to our Carrier again. These AFUEs, these are the best furnaces on the Energy Star site at this point in time. 98.5, but again, remember the smallest furnace in this series is a 60,000 BTU furnace, and its minimum input is 24,000 BTUs. So how do you think it's going to be performing when most of the demand is below 24,000 BTUs? It's going to be the same. It's going to cycle on and off and on and off because there's no way to be able to do it. It's not going to be cycling as much because it'll be able to modulate hopefully down to this range and then cycle a little bit in here, but it will still be cycling. Same with the Lennox, 23,000 BTUs. It's not going to do much better in that application where most of the demand is below 24,000 BTUs. So let's look at AFUE. So that AFUE number, and this is from Carrier, it says it's like ratings, it's like your car's MPG. The higher the number, the greater the potential for savings. So that's the key, potential for savings. And then we have the efficiencies can reach as high as 98.5. So I think they're acknowledging there that it may not be 98.5 all the time. It could be as high as 98.5. So a couple things to note. As we saw in the distribution, that 95% AFUE furnace, two-stage furnace, will not be 95% in the field because of this cycling depending on the heat distribution. If that 60,000 BTU furnace was installed in a home that had a heat loss of 45,000 BTUs, it would operate very well because it wouldn't be cycling. It would be in its range. It would be above the minimum input, right? The stage 1 was 42,000. So if it's 45,000, it's going to operate at stage 1 and just coast along very well at a high AFUE. No question about it. It'll be a good performer. But if the heat losses are below that, or the majority of the heat losses are below that, that's where we get into the issues. So this furnace and this furnace, even though the AFUEs are high, will have a problem making that. So the way I would like to look at it is this. Yes, okay, Carrier wants to say it's like the MPG. I would agree with that. But it's MPG highway. That AFUE number is MPG highway. That's kind of the best fuel rating that it will get on the highway. This would be on the highway when we're running full out. Unfortunately, the majority of our driving with our furnace, for example, it will be done at MPG city. And we know that the MPG city versus the MPG highway, those numbers are very, very different. And in the same way, the AFUE, when we're driving our furnace at these distributions, will be a lot lower than what our MPG highway is. So, all to say that AFUE number is not necessarily a reflection of how the unit is going to perform in the home. Really, it's about matching that minimum input and the maximum input to the heat loads of your home. When we can match both the maximum and the minimum and have the appliance be able to modulate down to both ranges, that is the ideal, and that's what we're looking for. So, to our friends at Carrier and Lennox, with this presentation, I'm definitely not trying to speak down about their product. If their product is installed in a home where the heat load is above that 23 or 24,000 BTU range, they're going to work very well. You're going to have great efficiency, great modulation, great comfort, great delivery. We're talking about whether those furnaces meet some of the challenges of these low load designs that we're seeing these days. And if they don't, is there another solution? We're just trying to point out this to the contractors that there may be an issue when we're not matching the minimum inputs closely enough, we're not looking at them. But I haven't tried to misrepresent any of their equipment. I've taken all the information from whatever's been publicly available. If I have made any errors or omissions, please let me know. I'll correct this immediately. I'm not trying to bamboozle or slander anybody. I'm just trying to present an issue that we see on the HVAC side, that is an issue that all contractors are needing to deal with and understand, so that we can implement solutions to these. So just to kind of wrap up, I think on the heating and cooling equipment, what we need is lower minimum inputs. We need better turn down ratios. And why? Because we need to be able to deal with the whole home loads, and we need to deal with partial loads. And if we're going to solve some of the stratification issues, the only way to do that is zoning. So now we're going to be taking those small minimum inputs, and we're going to be dividing them up even smaller. So we need to be able to deal with those part loads efficiently and comfortably. So the heating can't always be cycling, and the AC unit can't always be going into defrost mode to deal with these micro loads. If we don't deal with those, then the cycling will continue, the poor efficiency, the temperature swings, and the rooms that aren't comfortable will continue to be the norm, unfortunately. So again, thank you for your time. I hope this has been helpful. If you have any questions or feedback, you can reach us online at www.iflowhvac.com, or you can reach me on email, toll free, or by cell phone. So all of the information is there. I appreciate the time you spent with us. Look forward to any feedback or questions that you may have. And again, thank you for considering iFLOW. We appreciate it.